Okay, so this time we've got a resistance of 50 ohms. We've got a capacitance here of 47 microfarads, so micros times 10 to the minus 6. Our supply 120 volts, 50 hertz. Again, I've not put an angle in there, so you'd assume the angle to be 0. And up in the corner here, I've just put a wee reminder that when we add and subtract in rectangular form. And when we multiply and divide in polar form. So the same as the last time, when you're looking at that resistor, the impedance of the resistor is the resistance, so it's just that 50 ohms. The impedance of the capacitor is XC. XC, from what we did last week, XC is 1 over 2 pi FC. So it's 1 over 2 pi times the frequency of the supply, the 50, times the 47 times 10 to the minus 6. If you're putting all that in your calculator in the one, put it in brackets. So that gets you 67.73 if you're going to 4 significant figures. So these are both just values, but to have these as complex numbers, your resistance 50 ohms, that's 50 plus J0 ohms in rectangular. It's 50 and angle is 0 ohms in polar form. This 67.73 is a minus J, 67.73. Resistors are real, as in they have no J part. Inductors are plus J's, capacitors are minus J's. And as a polar number, this capacitor, 67.73, an angle of minus 90. These are all ohms. So now we have our value of our resistance, our capacitive reactance, and we've got all these in polar and rectangular. So the next thing you would do, same as the last time, is get your total impedance. So your Z total, you're going to add together the impedance of the resistor and the impedance for the capacitor. So because we're going to add them, we're going to do it in rectangular form. So our resistor is 50 plus J0, or just 50, you can leave it as that. And then it's plus minus J 67.73. So you could just have written that as 50 minus J 67.73. So remember, the minus J comes from your rules. So inductors are plus J's, capacitors are minus J's, resistors are real, so no J's. No, it's just one out my head. Just out my head. So because all your final answers should be in polar form, we're going to convert this. So to convert it in polar form, shift pole 50. And remember, this time you've got to put in the negative sign for the negative 67.73. Gets us a magnitude of 84.17. An angle of minus 53.56. And that's you get a ZT, a total impedance in the circuit. From that Z total again, we can go on and work out what our current would be. I equals V over Z. Just moving on from I equals V over R. Our V this time is 120, no angle given, so you take the angle to be 0. Your Z, 84.17, an angle of minus 53.56. We're dividing, so you divide in polar form. Divide your magnitudes, subtract your angles. So dividing your magnitudes, 1.426. And your angle, 0 minus 53.56 gets you a 53.56. And that would be your current. So if you're labeling that and you're drawing, that would be your current there. Back now, we check at that. So is this conversion here?
Yeah.
Okay. So it should be 84.19. Change that round in that last wee bit. Five. That changes that from a 6 to a 5. Are we okay with that so far? Okay, so we do our voltages now. So move that up a wee bit so I can still see that. So my voltage across resistor, V equals IR. Just take the current from there that we've just worked out. Times your resistance in polar form, which is that up there. Since we're multiplying, we're doing it in polar form. .25 at an angle of 53.56. And then for our voltage across our capacitor, I times XC, remembering that that XC has to be in polar form. Which we have down here on our page. So 1.425 times 67.73. Gets you 96.52, again to 4 significant figures. Add your angles. Gets you minus 36.44. And again, you'd have the choice of either converting these into rectangular form and adding them up, or drawing the phasor diagram. So I'll convert them into rectangular form first. I'll put that in red. Back into rectangular form for the two of these numbers. This from here, you've got 0 minus minus makes it a plus. Ah, sorry. And I'll convert this one as well. Put that in the middle. Going into rectangular form again. And I'll just add these up to check. Round into 4 significant figures, that gets you 120. It's not far off. So that's what we've got. Now leave the phasor diagram for this one and we'll maybe do it for the next example again. Any questions on that?